Welcome back, and let's get back to where we left off. Now that we've seen the numeric types of primitives in Java, which are byte, short, int, and long, we will go to floating number primitives in Java. We know that numbers can have decimal points. For example, this is a number 2, and in Java we call them floating point, decimal point numbers. Okay, so don't when you hear floating point numbers, this is what we mean. Okay, now floating point numbers, number primitives. Okay, the first one is going to be float. Let me see my float. Oops, Sublime Text is auto-correcting me. So the size of a float variable is going to be 4 bytes. You need to remember this. Or 32 bits. Total possible values is infinite. Now, this is not literally infinite. Obviously, there is you have 32-bit memory dedicated or 4-byte memory dedicated to it. So technically, it is limited. However, other side of technicality, it is not limited. You can store any number into a float that has a decimal point. However, this is something that you need to remember. Float is a single precision. Okay. Now, these are keywords that are, if we dive into explanation, will take another semester. Okay, because in computer sciences, these things are explained, these calculations are explained in detail. This is for a binary number to store, for a binary value, zeros and ones, to store a floating point numbers. It's a different science. So we'll not dive into that. But what you need to know is float is a single precision floating point primitive, in floating number primitive in Java, right? And its default value is 0.0. You're gonna have to have a point there, 0.0. And when you declare a float, you have to define f. This is a must. The same way when we declared a long, we put L at the end of the number. We have the same rule that applies to f. You're gonna see why real soon. Okay. What you need to remember about float, it's a single precision, 4-byte memory allocation or 4-byte container to store floating point numbers. Its default value is 0.0 f. And the second floating point number primitive in Java is double. Its size is double the size of a float, 64 bits. It has the same concept. It shares the same concept in terms of the values it can store. It is double precision. Okay, so we're going to look into precision now. Before we do so, let's look at the default value of a double, 0.0 D. However, in doubles, D is optional. Reason, let me add the star here. From in Java, the same way as int is a default number value, numeric value, double is also a default numeric value for floating point numbers, for floating data types. So since we have the same concept shared, let's take this line, oops, and add it to the end here. And this is going to be the end of numbers, so let's just add it here. Int and double are the default int. I'm sorry, let's do this. Int is the default numeric variable, and double is the default floating number variable. in Java. Okay, int and double. If anywhere in the code there is any kind of a floating point number, unless it is specifically defined to be f, Java is going to accept it as double and is going to allocate 8 bytes of memory to it. Okay. Now about precision. Special note about precision: you do not trust float or double per se for being precise. Again, this is another discussion for computer sciences, but in Java, 0.7 plus 0.1 is not equal to 0.8, okay? Because Java, when you do this calculation, which we'll look at later on, Java can return something like this, right? This is 9 to the 9 to the infinity. Okay, there is, because of this different type of approach to binary calculation of possible values, any floating number in Java is not always going to be precise. Either when you're going to work with these numbers, you cannot work with them when it comes to precision calculations. Okay, if you want to do, if you want to get precision up to single decimal point, you're going to need to round this number. Rounding this number to human eye is obviously rounded up. It can be rounded up to 0.8, right? So basically, these are equal, but not really. When you try to say is 0.7 plus 0.1 equal to 0.8 and ask this question to code this question and ask it to machine can say no. Okay, so again, do not use floating numbers for precision calculations. I will leave this here, and this will finish. This will bring to an end of the types of numbers in numeric primitives in Java. Two major categories: regular numbers and floating numbers. In regular numbers, we have byte, the smallest, with the smallest memory allocation. We have short, twice the size of byte. We have int, twice the size of the short, and we have long, twice the size of an int. Reason for byte, reason to use byte is for implementations that have limitations in memory. Short is where you, for example, if you want to store the year, obviously you're going to have to use at least short, because you cannot say 2019 for and say it's a byte. It can't work because 2019 is more than 127, right? And int is our default numeric variable. It has values up to 2 billion, right? You don't need to remember that. You need to remember the size of it. You can find 2 billion out of the, just by knowing the size of an int, which is 4 bytes or 32 bits, which gives you 2 to the power of 32 possible values. Divided by 2, you get the possible positive and negative values of an int. Long is used for bigger numeric calculations. It has 2 to the power of 64 possible values. And I believe it is right here. We have 1, 3, 6, 9 numeric 9 numbers after the 9 zeros, right? Here you're going to have 18 zeros. Now, floating point numbers, you're going to have float that will have to be declared with f at the end of the number. This is 4 bytes. If you want to save memory, you're going to use float. And you're going to have double, which is a default floating point number primitive for Java. It's going to be 8 bytes though, right? It's going to be a little bit of a heavy on memory. And its default value is 0.0. You can use D at the end, and I'm going to put here D is optional. Okay, because by default, again, Java is going to accept any floating number to be a double. Thank you very much. These are all our numeric variables in Java. Next, during next video, we will look at non-numeric variables, and we'll take it from there. Thank you.